Hi guys, welcome back. So the lecture for today will be on hypothesis testing. Just an introduction to hypothesis testing. We'll mostly be talking about definitions. And by the end of the section, you should be able to construct a null hypothesis, construct an alternative hypothesis, as well as you should be able to state the different types of errors that could be made in a hypothesis test. So a hypothesis test, we are trying to test whether or not something is true. We're going to make a guess about something, and we want to test whether or not it's true. So we have the two hypotheses that will be present in every hypothesis test, and that will be the null hypothesis and the alternative hypothesis. So it tells us here the status quo hypothesis is going to be called the null hypothesis. So by status quo, we mean what has tentatively or usually been assumed to be true about the value of something. So status quo hypothesis is null hypothesis. There will also be in every problem an alternative hypothesis, also called a research hypothesis. An alternative hypothesis is an alternative claim about the value of the same parameter that the null hypothesis speaks about. And we have that the null hypothesis we're going to denote H sub 0, whereas the alternative hypothesis we're going to denote H sub alpha. And then in these testing situations, we have a few different kinds of tests. So you may have what is called a right-tailed test. You may have what is called a left-tailed test, or you may have what is called two-tailed test. All right. So you'll notice that in each situation, the null hypothesis is the same. The null hypothesis is simply, it is what it is. And the alternative hypothesis is, well, it can be greater than what we thought, or it can be less than what we thought, or it can just be not equal to what we thought. So we would kind of like to think of these three pictures. Greater than what we thought, well, we're talking about this right-hand tail of our distribution. Less than what we thought, and we have this little tail on the left side of our distribution, or just not equal, and that might look like we have a little bit on both sides. So from the pictures, you can clearly see we have one situation where our test is a right-tailed test, we have a left-tailed test, we have a two-tailed test. So here, the strategy for constructing the hypotheses, first and foremost, is going to be to read the problem. Read the problem and search for certain keywords. Then determine which form of testing we're doing of the three. And then find the value of this mu sub 0 that shows up in all three. And that mu sub 0 should be the number that answers the question greater than what, less than what, or not equal to what in terms of the alternative hypothesis. So I know this is a lot of definitions and it might not be totally clear right now, but we'll do some examples in a minute and hopefully make it a little more clear. I also want to talk about ways that we can be right when we do this testing. We're looking for something, is it true, is it not true? We can be right or we can be wrong. And there are more than one way that we could be right or we could be wrong. So a nice example of this kind of idea is a courtroom trial. So you'll see here, if we in the court find the defendant not guilty when he did not commit the crime, then that's right. We're correct to find him not guilty if he did not commit the crime. So that would be equivalent to not rejecting the null hypothesis and the null hypothesis being true. So in the case of the courtroom scenario, the null hypothesis is that you are innocent until proven guilty. This is how the justice system should work. So that's one way to get it right. Another way to get it right would be to say that if he committed the crime, then he's guilty. That is also correct. And that would be equivalent to rejecting the null hypothesis when it's false. So if the null hypothesis is that he's innocent, we will reject it because it's false. So these are the ways that we could get it right. But we also know that there are ways that we can get it wrong. So we have two types of error. Type 1 error and type 2 error. Type 1 error is he's innocent in reality, but we found him guilty. So we find the defendant guilty, but he did not commit the crime. That is an error, and we call that a type 1 error. A type 1 error is when we reject the null hypothesis, but it was true. The null hypothesis is that he's innocent. We rejected the fact that he's innocent, but he actually was innocent. But there's another type of error we could make, which is kind of the converse of that. That would be he actually did commit the crime, but we let him go. That's also an error. And so that would be equivalent to not rejecting the null hypothesis, even though it's false. So the null hypothesis is that he's innocent. That is false, but we don't reject it. So that's another type of error. Okay, so hopefully that explains a little bit better what we're talking about here. We're going to look at some scenarios, and we're going to see if we can describe the hypotheses, figure out what the errors would be, and so forth. So the example says that for each of the situations below, we're going to provide the null and alternative hypotheses, describe the two ways a correct decision could be made, describe what a type 1 error would be, and describe what a type 2 error would be. So first scenario. Americans used to be, on average, the tallest people in the world. That is no longer the case, according to the study. The Dutch are now the tallest at 178 centimeters, followed by the Swedes at 177, and the Americans with a mean height of 175. And that 175 centimeters is approximately 5 foot 9 inches. According to the researcher, the average height of Americans has been pretty much stagnant for 25 years. Suppose that we conduct a hypothesis test to investigate whether the population height of Americans this year has changed. All right. Pardon me. So, part A. The first thing we need to do is provide the null and alternative hypotheses. So part A, provide the null and alternative hypotheses. So our strategy was to read the problem and to look for keywords. So keywords might be here. We're investigating whether the population mean height has changed. So the thing that we're investigating. All right, and maybe this is important, mean height of 175 centimeters. Okay, so the null hypothesis in this case should be that the mean is 175. So the researcher said it was 175. The null hypothesis is that it is 175. Our alternative hypothesis here should be that it's not 175. Might be larger, might be smaller. we're simply saying not 175. So we've done the first part of the question. The second part of the question is, describe the two ways that a correct decision could be made. So let's take a look. So if, excuse me, so if mu is not 175 and we reject the null hypothesis, or if mu is 175 and we do not reject the null hypothesis, then we're correct. So two different ways of being correct. Either the null hypothesis is false and we reject it, or the null hypothesis is true and we do not reject it. Then the third part of the question is describe a type 1 error, and after that we'll describe a type 2 error. So describing a type 1 error, and we can go back and remind ourselves, a type 1 error would be to reject the null hypothesis even though it was true. All right, so let's see. What would it mean to reject the null hypothesis even though it's true in the context of our problem? So a type 1 error would be, we know it's rejecting the null hypothesis even though it's true. So to reject HO when HO is true. I did not do that. Okay. Would be to reject HO when HO is true, which means to reject the null hypothesis when our mean is 175. On the other hand, a type 2 error would be the other one. A type 2 error would be not to reject it even though it's false. A type 2 error would be not to reject the null hypothesis when the null hypothesis is false. Okay, and that's all we needed to do for this problem. So let's see another example. Credit scores in Florida. According to creditreport.com, the mean credit score in Florida in 2006 was 673. Suppose that a hypothesis test was conducted to determine if the mean credit score in Florida has decreased since that time. So our strategy was to read the problem and to try to identify some keywords. So I think that this word decreased is going to be pretty important because that might tell us which type of test we're doing, right-tailed, left-tailed, or two-tailed. If we go back and look at the previous one, the previous example just said has changed. It didn't say it went up or it went down. And so that's why our alternative hypothesis was just is not equal. But here we're told decreased, so I think we're probably going to be talking about either a right tail test or a left tail test. And the mean given in the problem was 673. Mean credit score? Mean credit score is 673. So my null hypothesis here, and we remember that the null hypothesis was always just that it's equal to something, right? That's this column here that I'm talking about. So in all three situations, the null hypothesis was mu equals mu naught. Okay? So our null hypothesis should be mu equals, and we're looking for that number mu naught. In this problem, that should be 673. In this case, our alternative hypothesis, we're given this hint that we should test if it has decreased. So the alternative hypothesis would be, no, it's less than 673. So null hypothesis, the mean is 673. Alternative hypothesis, the mean is less than 673. All right. Now we need to say, in the context of our problem, what will be making the correct decision? So the correct decision will be made if we reject the null hypothesis when mu is less than, sorry, not equal to 673. If we reject the null hypothesis when mu is less than 673, or if we do not reject the null hypothesis, when the mean is actually equal to 673. So that makes sense, right? If the hypothesis is that the mean is 673, and the mean is in fact 673, then we should not reject that hypothesis. Similarly, if the mean is less than 673, then we should reject the hypothesis. Okay, so what is a type 1 error in the context of this problem? So remember, a type 1 error occurs if we reject the null hypothesis, but it's actually true. So a type 1 error will occur if we reject the null hypothesis but the null hypothesis was true. So then a type 2 error should be the other type, right? A type 2 error will occur if we do not reject the null hypothesis when it's false. That's pretty straightforward. All right, we have one more scenario we want to look at. We're going to do the same things, A, B, C, and D. So this is salary of college graduates. According to U.S. Census Bureau data, the mean salary of college graduates in 2002 was $52,200. Suppose that a hypothesis test was carried out to determine whether the population mean salary of college graduates has increased. Okay, so our strategy was to read the problem carefully and to try to identify information that's important. So again, I think this word increased is pretty important. That should give us some idea what kind of a test we're doing. And also this mean salary, that should be pretty important. So if we want to identify our null hypothesis and our alternative hypothesis, well, we know that the null hypothesis is just always going to be mu equals mu naught. And mu naught in this case, well, that should be the number given in the problem. So the null hypothesis is that the mean salary is 52,200. Then the alternative hypothesis should be, the problem tells us we want to see if it's increased, so greater than. Alternative hypothesis, the mean is greater than 52,200. So that's a right-tailed test. All right. Then the next thing it wants us to do is describe how can we be correct in the context of this problem. So the correct decision will be made if either we reject the null hypothesis when the mean is greater, or we do not reject the null hypothesis when the null hypothesis is true, when the mean is 52,200. Okay, so those are the two ways that we can be correct when we're doing this test. Now we want to think about our two types of error. So a type 1 error will occur. And we remember that a type 1 error means that we've rejected our null hypothesis, but it was true. So we made a mistake. A type 1 error will occur when we reject H0 when the mean actually is 52,200. But we could make one other type of mistake. We could make a type 2 error, and that occurs if we don't reject the null hypothesis, when it's false. All right, I believe that's the last question in this lecture note. So I hope it's a little bit more clear now what we mean when we talk about null hypothesis, alternative hypothesis, hypothesis testing, right-tailed, left-tailed, two-tailed tests, and types of error. So again, remember, your learning objectives for this lecture are to be able to construct the null hypothesis, to construct the alternative hypothesis, and to state the two types of errors. Type 1, which occurs when we reject the null hypothesis even though it's true, or a type 2 error, which occurs when we don't reject the null hypothesis even though it's false. So again, if you have any questions at all, please do reach out to Dr. Doss.